So today we are going to set up the Diels-Alder lab, and the first step in setting up that Diels-Alder lab is to start up our gas chromatograph so that it'll be ready to go when we need it. So we're going to open the air and the helium and set that pressure in the air cylinder up to about 60, and we can open the flow. And we're going to set the pressure in the helium up to about 80, where that line is, and open that flow. And then we need to open up the hydrogen cylinder, set its pressure up around 50, I believe. Maybe it's 60. And then open that. Right now there's still nothing flowing because these valves are all shut. We're going to be using just this one instrument, which is Raphael. So we're going to open up the helium, the air, and the hydrogen gas flow to this instrument. And we'll notice that here we have a carrier P2 pressure of 90 kilopascals. The makeup carrier P1 is at 50, the hydrogen is at 60, and the air is at 50. Those are the correct settings. I'm going to change the septum in here because I'm not sure when that was last done. So it may be that it's already somewhat compromised. And just replace that with a nice clean one, because I'm going to be following this reaction over time and making quite a few injections. So I'm just popping open a new septum. You may be able to hear a little bit of gas escaping because I turned on the gas pressure. So we're going to put that septum in there. And then on top of that we get our little needle guide. And that all screws down. And get that lined up. And we want to tighten that, but not too tight, or it'll be very difficult to get the needle in and out. Tight enough to prevent leaks. So just to check to make sure that's seated well, I'm going to straighten this needle out a little bit on this syringe, and then I'll put that in there and see that if I kind of point it straight down, it should go in easily, right, which will allow me to make my injections. So now I want to turn on the GC instrument and the heater, and turn on the CBM 102. This is a communications bus module that sends the data to the computer. And then I'll unsleep my computer here. And unlock it. Password is chemistry1114 for all the departmental instruments. Hopefully I now have a camera angle that works for you to be able to see what I'm doing. So we're going to open up the GC real-time analysis software. And I always have to give it permission to make changes to the computer. There is no password for the administrative account. And it's connecting the GC instrument. And you'll see that it's going to do some things here. And will tell me that the link is okay. Gave me that beeping sound that told me that I have a link to the instrument. We want to turn the system on. And we want to make sure that we've loaded the method Diels-Alder Kinetics Raphael 2020. So I'm going to open the method file. And it's probably in my Kinetics 2020 folder. There should be a Diels-Alder Kinetics Raphael 2020. And we're going to be doing cyclohexadiene and N-phenylmaleimide. So this is the correct method here. It's got the lab that we're running, the instrument we're on, the year. Well, it's 2021 now, but I'm using the method from last year. And then the compounds are cyclohexadiene and then phenylmaleimide. So I'm going to open that method, and then I'm going to turn the system on, and I would like to download the instrument parameters because I've opened the correct method. And it's going to take a little while to transmit. I do want to open up the oven and make sure that the column that's in the oven is in fact this RTX5 column, and that no one has changed it. So that's the ResTech Corporation column, phase RTX5. So that is in fact the column that I need in there. So the parameters are now downloaded, and it is starting to heat these up to 275 degrees for the injector and the detector, and the column temperature of 190, which is pretty hot. The max temperature on this column, if we look at the column, is 360. So it's a long way from the maximum temperature, but it's a reasonably high column temperature. It's a 15 meter by 0.25 millimeter inner diameter column with a film thickness of 0.25 and RTX5. RTX stands for ResTech, which is the company that makes the column, and 5 is 5% diphenyl, the remainder 95% dimethyl polysiloxane. Pretty simple temperature program. It starts at 190 and rises rapidly at 40 degrees C per minute until it hits 266, and then holds there at 1.2 minutes. So we have a total of a 3.1 minute run. And what that's going to do is allow us, after it cools back to 190, to take a data point every 6 minutes over a 90-minute period, so we can get lots of data points to get accurate kinetics. The injection port is at 275. As I said, the detector temperature is at 275 also, with a delay time of 0.8 minutes so that we don't see our solvent, ethyl acetate, in our run. The range is 1, right, which means that the sample, the signal that's sent to the computer is divided by 10 versus what's actually being generated by the instrument. And the sampling rate is not something that's generally something you need to worry about. Once these temperatures reach 100, I can light my detector. So to do that, we're going to make sure that our little hole is in the back. And then we're going to briefly depress this to cut down the amount of air while we light it. And you hear a popping sound. The other thing I'm going to do is I'm going to make sure that the split is set correctly. So I'm going to close it all the way down. And I know that I want it to be open a total of 6 turns. So once it's closed all the way, I'm going to open it 1, 2, 3, 4, 5, 6 turns to give me the right split. Unlike the GC mass spec instrument, on this case, we can't actually set the split to like 130 like we did on the other one. We have to just gauge it by opening it. To check that the detector's really lit, I'm going to hold this watch glass back, and I'm going to make sure that there's condensation occurring on the watch glass. So you can see that there's condensation coming on the watch glass. That means that there's actually a fire burning in there. And maybe it's not obvious, but if I kind of rub my finger on it, you can see condensate. So I have a lit detector. And now what I want to do is I want to let this equilibrate so that the temperatures are at 275 and 190, and after it's fully equilibrated, I'll zero the system to make sure that the baseline is in the right location. And so you can see that there's the baseline. This is times 100,000 right now on the microvolts, but what I'm going to want to do is zoom way out, or zoom way in rather. Right, so I have a much more sensitive, and you can see right now it's very choppy because it hasn't reached the equilibration temperature, and it's not at 0 either at the moment. But there's no point zeroing it now because that's all going to change as the temperatures change in the system. So the GC mass, or the GC instrument, is now set up ready to go. Just needs to equilibrate for about half an hour.